Hello class, today we're going to talk about section 9.8, which is geometric sequences as exponential functions. By the end of today's lesson, you'll be able to find the next terms in a geometric sequence. You'll be able to write the sequences out as exponential functions, and you will also be able to identify the difference between geometric and arithmetic sequences. A geometric sequence is an ordered list of numbers, where each term can be found by multiplying the previous term by a constant. So what this means is we are using multiplication to get from number to number. The number that you are multiplying by, that constant, is called the common ratio. You can find this by dividing any pair of previous terms. For example, taking the second term and dividing by the first, or taking the fifth and dividing by the fourth. So dividing any two consecutive pair of numbers, bigger one minus the smaller one, or second number minus the first one. So for example, in this first one, we are looking to find the next three terms in this sequence. We start with 9, 3, 1, and 1/3. To find the common ratio, I'm going to take the second term and divide by the first, which is going to give me an answer of 1/3. So then to find the next term, I'm going to take my last term, which is 1/3, and multiply by the common ratio, which is also 1/3, and get 1/9. To find the next term, I'm going to take 1/9 and multiply by the common ratio of 1/3 to get 1/27. And to find that third term, I'm going to take 1/27, multiply by the common ratio, and get 1/81. Same thing works over here with our next sequence. I'm going to take the second divided by the first, which gives me an answer of 1.5. I'm then going to take my last term that I have, which is 81, and multiply by 1.5, which is going to give me an answer of 121.5. I am then going to take 121.5 and multiply by 1.5, which is going to give me an answer of 182.25. And then we're going to take that next term in the sequence, 182.25, and multiply by 1.5 to get an answer of 273.375. So those are your next three terms for both of these sequences. First, we found the common ratio, then we multiplied by that to find the three terms. Go ahead and try this one on your own. Taking -4 and dividing by 1, the common ratio is -4. Multiplying by -4 over and over, we get 256, -1024, and positive 4096. Geometric sequences can be expressed as an exponential function. So that's how that ties back into the second half of this chapter 9, is we're writing it as a function with an exponent variable. What this is saying is a to the n. So the nth term in the sequence, that stands for any number in the sequence, is equal to the first term, and then the r in this case stands for that common ratio. The n stands for whatever number you are looking for, and then -1. It might be helpful to remind you that that exponent needs to be solved first, so it's helpful for you to put parentheses around it. That is acceptable. So we are looking for the nth term. In this case, it's going to be the 10th term in the sequences. Our first job, similar to finding the next term, is going to be to find the common ratio. So I'm going to take 48 and divide by 96, which is going to give me an answer of 1/2, or 0.5. I'm going to write out a geometric equation now. You are required to write it in n format first. So a to the n is equal to the first term, which is 96, times your ratio, which is 0.5, to the n minus 1 power. This is writing it out in nth format first. Now we're going to go ahead, since it asks for the 10th term, is say a10 is equal to 96 times 0.5 to the 10 minus 1 power. My suggestion to you when you plug that into the calculator is do 96 times 0.5 to the 9th power. It's very simple for you to do 10 minus 1 in your head, and it's going to save you time and energy with the parentheses in the calculator. So the 10th term in this particular sequence is 0.1875. You're going to want to include the full decimals on these. We want to avoid rounding. Same thing is going to happen with this second example. I'm going to take second term divided by the first in order to find my common ratio of 5. Writing out the AN equation, I get AN is equal to -3, in parentheses, -5 to the n minus 1 power. You can either write it with the multiplication symbol or in this parentheses version. And then we're going to go ahead and find A10 by plugging in 10 for our n value. Again, I recommend that you solve that exponent, so the 10 minus 1. I recommend you do that in your head prior to putting that into your calculator. And we are going to end up with A10 is equal to 5,859,375. So steps, find your common ratio, write the AN equation, and then plug in to find the value you are looking for. Go ahead and try this one on your own, looking for the 9th term in this sequence. So we've got our common ratio of -2, our AN equation, and then plugging in to find A9, we get -1,536. Last thing we want to talk about is the two types of sequences that we have looked at. Geometric sequence is what we are talking about right now. That's using multiplication to get from term to term. Arithmetic sequences we looked at earlier in the year when we were looking at linear equations, and that is adding a number to get from term to term. So our job now is going to be to differentiate between these two possibilities. If it doesn't have multiplication or addition, so there is no constant between them, then we would say it is not a sequence. So looking here, I've got 4, 9, 12, and 18. First thing I always like to check is, do we have an arithmetic sequence? So I'm going to start with 9 minus 4, which gives me 5. 12 minus 9 gives me 3. Those two values are not the same, so this is not an arithmetic sequence. Then I'm going to go ahead and check 9 divided by 4, which is going to give me a value of 2.25. I'm then going to check 12 divided by 9, which gives me a value of 1.3 repeating. Again, this does not match up. So this is neither an arithmetic nor a geometric sequence. Neither of the patterns worked. We're going to go ahead over to the next one and try again. So I'm going to say -15 minus -20. Minus a negative turns into a positive, which is going to give me a value of 5. I'm then going to check the next one. -10 minus -15. Again, double negative turns positive. I have a ratio of 5. So far we're good, but I have one more number in the sequence to check. So -5 minus -10, positive, turns into a 5. Since we get the same value when we are checking every time with addition, this is going to be an example of an arithmetic sequence. So this is an example of an arithmetic sequence. Go ahead and try to identify this one on your own. Starting with the arithmetic, subtracting, we get a different ratio every time, so that does not work. However, when we come to the geometric and divide those previous terms, we get a 0.5 ratio for all of them. So this is, in fact, a geometric sequence. If you have questions about this or anything else from the lesson, please let me know when you get to class.